Now, this is the simplest possible curvilinear coordinate system, and this is in 2 dimension, but mostly we will deal with 3 dimensional systems. So, we need to go for curvilinear coordinate systems and we need to introduce it in a general fashion. So, we need to first understand how to find out unit vectors in a curvilinear coordinate system. So, if we consider in 3 dimension a vector given by r equals x x cap plus y cap plus z cap, then, and if it represents a point P in space, then we know x cap, y cap and z cap, these are the unit vectors along x, y and z direction. Now, if we consider that the same vector r is represented in a curvilinear coordinate system as a function of u1, u2 and u3, 3 coordinates, and we can consider a tangent vector to the u1 curve at point P, for which u2 and u3 are constant. That means we are talking about del r del u1. This would be a tangent vector in the u1 coordinate on the curve represented by r, and the direction of this tangent vector can be given as del r del u1 over the magnitude of del r del u1, like this, and this can be called the first unit vector E1. And that means if we have h1 being the first coordinate, then del r del u1 can be written as h1 e1 unit vector. That means h1 is given as the absolute value of del r del u1, this. Similarly, we can find E2 and E3 using the tangents from U2 and U3 curves at point P, and then we have all the unit vectors. Now, we can consider the gradient of u1. This is a vector at P that is normal to the surface u1 equals c1. So, this is the gradient of u1. This vector is normal to the surface u1 equals c1. Then a unit vector along this direction can be given as capital E1 unit vector is the gradient of U1 over the absolute value of the gradient of U1, like this. Similarly, E2 and E3, I mean capital E2 and capital E3 can be written as gradient of U2 over the absolute value of gradient of U2 and E3 equals gradient of U3 over the absolute value of the gradient of U3. We can write it this way. So, these capital E1, capital E2, capital E3, these are normals, these are unit vectors normal to the surface, while small e1, small e2 and small e3, these are unit vectors tangential to the surface. If we want to represent a vector given by A, vector A can be represented in terms of the unit vector small e1, small e2, small e3 or capital E1, capital E2, capital E3. In terms of small e1, small e2, small e3, it would be A1 E1 plus A2 E2 plus A3 E3. Similarly, in terms of capital E1, E2, E3, we are using small a1, a2, a3 and capital E1, E2, E3. I will in a minute explain what that means. We can represent it this way, where small capital A1, capital A2, capital A3 or small a1, small a2, small a3, these are the components of A in each system. And how we have found out the system? One was from the partial derivative of the position vector with respect to u1, u2, u3, and the other one was from the absolute value of the gradient of the unit vector, sorry, absolute value of the gradient of u1, u2, u3. That way we found these components. We can write it in any of the ways. In other words, we can represent A as, in the first notation here, C1 del R del U1 plus C2 del R del U2 plus C3 del R del U3, that is C1 alpha 1 vector plus C2 alpha 2 vector plus C3 alpha 3 vector. And so this is this notation here, and the other notation would be like, we are writing it here, A is given as C1. Of course, these this C1 and this C1 are not equal. Gradient of U1 plus C2 gradient of U2 plus C3 gradient of U3, that is equal to C1 beta 1 plus C2 beta 2 plus C3 beta 3. So, we have found out how unit vectors are calculated, and so these capital C1, C2, C3 that we have obtained in this notation, the first notation, are called the contravariant components, while the small C1, C2, C3 that we have found in the second approach is called the covariant components.